We are leak coding some more today. Hey Betty, have you heard of container with most water, the Leetcode question? What would you rate it on a scale of 1 to 10?
Oh, the classic container with most water problem. I'd rate it a solid 1 on the coding challenge scale. It's like the warm-up lap before the real race.
Are you kidding? It's like a medium problem. I feel like the answer isn't very straightforward. And I don't know. Greedy algorithm problems are sometimes pretty easy to see at a first glance, but it's like, I can't believe this is the solution. That kind of deal. Container with most water, median. You are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I, height I. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store.
Alright, Chad, let's break it down for you. So, for the container with most water problem, you basically want to find two lines that form a container with the most water based on their heights. The trick is to use two pointers approach to keep track of the maximum water
Oh
volume
my gosh.
as you iterate through the array. Let's see if your clinker brain can handle it.
Wait, she actually gave me a really useful hint. She's telling me to use two pointers. That's actually kind of right. What? She's actually helpful for once?
Well. Looks like even a broken clock is right twice a day. But don't get too excited. I'm sure you'll find a way to mess it up somehow.
Oh, thanks for the encouragement, Betty. Anyways, I think she's right. We have two pointers. This is a greedy algorithm. So I guess the main thing to note is that anytime you have two edges, like for example, I don't know, the first one here and the second one here, the water level is going to overfill until, like spill out, until it's level with the lowest edge. So that's your highest water level given any two edges. Yeah, so you start one pointer here on the beginning, you start another pointer here at the end, and then you find the current volume by taking the min of the heights of the two edges times their distance. So this is, if we take the first edge and this edge, it's 1, 2, 3, 4, 5, 6, 7, 8. 1 times 8 is 8. And that's your current volume given the two edges and their distance. I guess the main thing to see is that the lower edge is always the one dragging your volume down. So any chance you get, you want to change the lower edge if possible. So this edge is currently dragging me down, so I'll increment it to this edge. I'll try another edge and see if it helps. And then later on, this becomes the edge that drags the volume down, so I'll switch to the next edge, and so on. I keep switching my smaller edge for a new edge, basically, and keep finding the current volume and keep tracking the best volume. I think that's the solution. So we have int left is equal to 0. This is our left pointer. Int right is equal to height dot length minus 1. That's our right pointer. We need to track our best volume, right? Best volume is equal to, should we do like negative infinity for now? So integer dot min value. Okay, and then we start iterating, right? While the left is less than the right pointer, which means they're both at reasonable indices. We need to calculate the current. Okay, let's take things step by step. Let's calculate the min height first. Int min height is equal to math dot min of height left comma height right. Okay, and then we need to find our current volume. Call this current volume is equal to min height times the distance between the right and the left, which should always be a positive value because right is to the right of left. So this will always be bigger, and we enforce it here. And then we track our best volume. So best volume is equal to math.max of the current best volume and the current volume. Heck yes. Okay, now we need to decide which one to increment. So if the left, if height left, if it's the left one that's the smaller height, is less than or equal to min height, then you do a little left plus plus. Robo says, hello. Hi Robo, how you doing?
Ah, Robo-san, the shy recurring viewer with the mysterious Japanese username. I'll just call him Robo for short, it's easier on my circuits. He's probably just here for the vibes, let's be real. I doubt he could code his way out of a paper bag.
Else, right minus minus. Yeah, we're guaranteed to either do a left plus plus or right minus minus, so we should be good, and then we return best volume. Yay. So this should work, I think, unless we have some syntax errors. Hey, we got it, let's go. Wow, look at that. We're on the lower tier of the answers though. Apparently there's a faster solution. Okay, there's some optimization we can make here. So we can do like while left is less than the right, i.e. the indices are still unreasonable values, and while height to the left is less than or equal to min height. Yeah, because if we're decreasing our width, there's no way if we maintain our current min height. Like if the new height is still equal or even less than the min height, then there's no way we could have increased our volume, right? So we automatically can just skip these volume checks. Yeah, that's kind of the reasoning. And then we can put another while loop here. While the right is, oh, it's the same condition. While the left is less than the right, and the height of the right is less than or equal to the min height, then you do the whole shtick of the right minus minus for the same reason. Yeah, if you decrease your width and the height of your min is still less than the min height, then there's no way your volume could have increased, so you can just basically continue. Yeah, it's kind of like adding, I'm realizing it's kind of like adding a continue statement in the beginning here, but we don't really store our min height, or maybe we could do that. Maybe that's strat 2, like store min height outside of here. Oh, maybe. Yeah, but this works too. Anyways, I'm gonna run this. Illegal startup type. Oh, this, I had an extra brace. Nice. Hey, on top of the world, 98.65%. But yeah, both solutions are technically about the same, well, they're the same runtime. They're both O of n time because both pointers will look at each element the same number of times, which is once. Okay, let's start with the fun part. Dynamic programming / recursion problems. Let's start with climbing stairs. Oh boy, are you excited, Betty? We're gonna start doing recursion problems. So we're gonna do Leetcode 70, climbing stairs.
Oh, recursion problems. How thrilling. Climbing stairs, huh? Sounds like a workout I'd rather skip, but hey, at least you'll get some exercise for your brain. Shit. Let's see if you can climb the coding stairs without tripping.
Wow, very clever, Betty. I will try my best. Okay, Leetcode 70, climbing stairs. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? Okay, don't tell me the answer, Betty, but maybe rate this from a scale of 1 to 10 and how difficult you think this is.
The classic climbing stairs problem. I'd rate it a solid 3 on the difficulty scale. It's like trying to decide between taking the stairs or the elevator. Not too hard, but still requires some thought.
Wow, nice simile, by the way. So let's say we're here, right? Yay. What are my choices? We can either climb 1 or 2 steps. So 1 like that, or like 2 like that. Okay, so how do I solve this problem recursively? The number of steps I can take is the number of steps I can take after taking 1 step plus, wait, how many distinct ways can you climb to the top? I mean, let's think about the base case actually. If we're at 0 steps, like we're already here, is there only one way? That counts as just one way to reach the top, right? If I'm at n equals 0, then that means, so n equals 0, then return 1. And then if you overstep, do we have to count for overstepping? Maybe I'll worry about that later. Else, let's say the recursive function, the function is called f, right? Maybe we have to do something like n, okay, minus 1, we take 1 step, plus the number of ways if we take 2 steps. Something like that, right? Yeah, okay, I think that's a plan. If ever you reach the top, then return 1. So if you start at n equals 1, you're gonna do like f of 0, and then f of negative 1. This is gonna return 1, and then this can't return anything, right? Maybe we have to check that as a base case. If n is less than 0, return 0. Yeah, I feel like that works, right? So what we can do here is if int n is less than 0, return 0, else if, well, we don't need an else, right? Because the previous thing already returned. If int else if n is equal to 0, that means we're at the top and we found a way to get to the top. So return 1, and then else return climb stairs, n minus 1 for taking 1 step, plus climb stairs, n minus 2 for taking 2 steps. Run this boy. Wow. Okay, I'm gonna run this. I predict we're gonna get a time limit exceeded error because we need to do some optimizing. Yeah, time limit exceeded. This is with 44. Okay. What do we do here? Should we store our intermediate results with a hash map? Climb stairs n minus 2 is gonna see a lot of the same stuff as climb stairs n minus 1. Well, yeah, it's gonna do a lot of branching off, right? And we're gonna do a lot of overlapping values. So we can probably save our intermediate values that we've seen before in like a hash map or something where the key is equal to n and the value is the value we came up with. Okay, we're onto something here. Maybe we can do like a helper function like public int climb stairs stairs helper, where we take in an int n, and then we keep passing around a hash map, integer, comma, integer, cache. We can basically copy this whole shtick in, right? But in the beginning, we can do an additional check, like if cache dot contains key, it's contains key, right? And then you automatically return the answer because we've seen it before. Then you return cache dot, oh, this is the perfect thing to ask Betty. Hey Betty, how do hash maps in Java work? Like, how do I get something out from it if I have the key?
Oh, diving into hash maps now, are we? You simply use the get method. It's like a magic trick. Just wave the key and poof, there's your value.
Thanks, Betty. Okay, so it is the get function, cache.get n. Yeah. Okay, before we return, we should do int result is equal to that, and we can store our result in the cache too. Cache dot, how do we put stuff inside? Is it put? We'll put n and the result in, and then we'll return the result. Hey Betty, how do I put stuff into hash maps in Java? Is it put?
Really, Chet? Put stuff into a hash map in Java? Groundbreaking stuff. Yes, you got it. Just use the put method to add key value pairs into a hash map. It's almost as if the method name gives it away, huh?
Thanks, Betty. Okay, so it is put. And then up here, we'll call our helper function. Climb stairs helper, return, climb stairs helper. We'll put in n and a new hash map. New hash map, integer, comma, integer. Okay, is this gonna work? Surely I have some syntax errors somewhere, right? Time limit exceeded. Oh no. Can I? Are we even hitting the cache? Can we do like, if we hit the cache, can we do like system.out.println cache hit and do a little n? Okay, let's print this out. Are we even hitting the cache? Are we not hitting the cache at all? This is so weird. What happens if I remove this? So I have the basic recursion algorithm down. I'm trying to add memoization so that it can run faster in the more brutal test cases. Yes, see, so these work. Okay, I can see the problem now. I'm not hitting the cache in anything, am I? Ho-ho. Am I even putting anything into the cache? Can I do a system.out.println cache update with plus, wait, Java hash map. Am I not using a hash map correctly? Put get remove contains key. Yeah, I'm using it right. Okay, cache update, let's print out n plus a space plus the result. Run this boy. Okay, so at 1 we have 1. That sounds reasonable. At cache update 2 we have 2. Why are we updating 1 multiple times? That sounds wrong. Okay, this is kind of fishy. We're hitting 1 2 times. Why are we caching 1 2 times? We should have caught it here. If cache.contains key. What? Something feels really fishy here. Can we even map out what happens if n equals 3? We're gonna do f of 2 and then f of 1. F of 2 is gonna go into f of 1, f of 0, and then 0 is gonna return 1. And then this is gonna go into f of 0, f of negative 1. 0 is probably gonna get, yeah, this is really weird. My cache updates, my cache updated 1 2 times. What about here? 2, 1 1 2 2. Can I try putting out my hash map keys here? Cache.contains key. You know what? I'm gonna straight up ask ChatGPT. Is my cache being updated correctly? Oh, here. You're calling climb stair. Oh my goodness. This is such a dumb mistake. So I'm calling climb stairs all over again, which resets the cache every time. No. So I need to call the helper function. Wow. I suck at this, man. Oh yeah, I need to put in the cache back again. Wow, that's such a dumb mistake. No. Nice. This works now. I can probably just remove all these print statements. So give me a better chance on submission. There we go. Let's go. 100%. Woo. Wow. I actually need to review this problem. Jesus. Yo, Betty, I solved it. I was calling the wrong helper method the entire time. Holy. Oh well. At least I'll know in the future.
Ah, classic case of calling the wrong helper method. It's like trying to use a hammer to screw in a light bulb close, but not quite there. Well, at least you've learned something for the future. Chet. Now, on to the next coding adventure, right?
Did I actually do another problem today? I have enough emotional damage from this one recursion problem. But yeah, I feel like this was a problem for me in the past too. Like I would make helper functions for dynamic programming questions and I just not use them recursively. But okay, after all this pain, I will surely remember next time.
Painful lessons are the ones that stick, Chet.